Hi Algebra 1 students, I hope you're doing well today. It is Wednesday, May 13th. I hope that you had a lot of good success with the chapter review on Tuesday and Monday. And so we're going to have a test, but in the meantime we're going to keep moving on. Chapter 13 is actually a really fun chapter. It's about probability, so it's a little bit different, of course. There aren't equations like there has been in the last semester, but it's just a really fun thing, and it's a very important thing. Many decisions are made in companies and businesses and studies, different biological studies, all kinds of things about probability. It's the likelihood that something will happen. Insurance companies use that. That's how they decide their rates. How likely is it somebody who's 25 is going to have a car accident versus 35, 45, what their life is like. It affects all of those things, and that affects what rates they charge. So that affects your parents' bottom line, their pocketbook, and it will you in the future too. There's many ways that probability is really important, but to make it more fun for you in this chapter, we use a lot of games. Like you can remember maybe playing Chutes and Ladders. There was a spinner. You know, you'd be sitting there, it's 1 through 6. Are you going to get that 5 or 4 that you need to go up the huge ladder from 28 to 72? I remember it well. And so what we're going to talk about is something a little bit more fun with games, but there are very real, very important applications of probability out in the world. That's why it's important for you to learn it. Okay, so let's say a prayer. Father in heaven, we just thank you for this day. I pray for all of my students that you would help them to master this material, to learn it, to enjoy it, and that you'd strengthen me and help me to be the very best teacher I can be right now. In Jesus' name, amen. Okay, well, I wrote out a lot of our notes already, so I'm going to go kind of fast through some of those things. I'll read them, so feel free to pause at any time you need to in order to catch up taking your notes. Okay, so here is chapter 13.1, and we're talking about what probability and odds are. Odds are different than probability, and you've probably talked about this, and you may watch March Madness, and they talk about what is the probability that this team will win or another team will win. But there's a lot of math behind it. There's very concrete numbers and proven concepts and theories that actually drive how all of these things are created. So it's not just kind of a general topic. It's very specific and it's almost scientific. So let's get going. We need to have some definitions. So the first one is outcome, and that is a possible result of an experiment. So obviously that makes sense, the outcome of something. But in terms of probability, that's what this is. And the second thing is, word is event. That means something happens. They call it an outcome, but I don't really like that. And for example, something occurs. So like the rolling of an odd number, or the spin on a wheel, or the picking out a marble out of a hat. That would be an event, okay? And the last thing we have is sample space. A sample space is a set of possible outcomes. So more than just one thing. So you might have, a lot of different things together. Okay, so let's use an example and see if we can better understand these things through an example. So here's number 1. You flip a coin once and roll a die once. List the possible outcomes. Okay, so we have 2 events happening here. We have a coin, and then we have the roll of a die. So one affects the other. All right? So for the coin flip, we have heads or tails, right? Now that's the first event. The second thing we have is the roll of the die. All right, so if the first thing we did, the coin flip, the result was a head, then to go with that, we could have a 1 on the die, a 2, a 3, a 4, a 5, or a 6. Okay, so there's 2 events. Or, let's say for the coin flip, we got a tails. So the first thing that happened was the tails, and then when we roll the die, we could have 1, 2, 3, 4, 5, and 6. So we want to list all of our possible outcomes. And how we do that is with symbols. So we would say heads 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, and then tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So this is my list. How many are there? There are 24, no, there's 12 possible outcomes, okay? You don't actually have to do this, but doing that helps you to visualize it and write it down so you don't forget any. You have to be very careful not to forget anything. Okay, let's do a couple more definitions. Or no, we're going to have an OIO. So what I want you to do is to list a bunch of outcomes. But this time, we're going to have 2 coin flips and 1 die. So we have 3 events. So when you're listing them, you can use symbols like I have here. Heads, heads, 1. So if in your first flip you had a heads, and then in the second flip you had a heads, and then you rolled a 1. And there's going to be more. There's going to be heads, heads, 2. What would be after that? So go ahead and pause the video and write down all of those possible outcomes. Just so you know, in this case we have 3 different events. So the sample space would be all 3 together, which is what our problem is, but we have 3 events. We have 1 coin flip, and then a roll of the die. So that's 3 different things happening. Okay, go ahead and pause the video and we'll come back in just a minute. Okay, so I wrote them all out already. And here they are. So we have the rest of the head, head, and 3. And then the next set of possibilities would be heads first, and then instead of heads on the second one, we had tails, and then 1 through 6. So that's the first set. And then what if on the first flip we had tails instead, but we still had heads, and then each number. And then what if we had tails and then tails, and we had each number? So it works out to be 24 outcomes for these 3 events. Now, fortunately, you're going to see that as we move through the chapter, there's a formula for this, so you don't actually in the future have to write them all out. So these help us to understand what the formula tells us. So it's very important to understand what outcomes are, and that's why we do these, but then the formula will later make it easier. Okay, now we have a couple more definitions. The probability of an event is the likelihood a particular event will happen. Okay, so that's the likelihood. So it's a fraction. Okay, so it's often like 25% likely, or you could write it as a percent or a fraction. 1/4, it's 1 out of 4, 25%. It's part of a whole, okay? And you'll see that with the next definition. Now we have two kinds of probability. One is theoretical and one is experimental. Now with theoretical, this is you are posing a hypothetical situation, like if somebody picked something at random, or if this happened, it hasn't actually happened, but we're just talking about it. That's theoretical. It's a theory. Okay, so that would be favorable outcomes out of possible. Okay, and this is where we get our fraction, because you assume that possible outcomes are all the possibilities, and then the favorable is the part of the possible that we want. Okay, favorable outcomes is that's what I want to happen, as opposed to unfavorable. Okay, we'll get more into that later. All right, so now I want you to write this down. You design t-shirts. The table below shows what you made. A student chooses a t-shirt from a box randomly. So this is hypothetical, theoretical. What is the probability that the student chooses a red t-shirt? Okay, I'll tell you a little bit more information. That's what was important. You're selling t-shirts to raise money, and you have different colors and different designs. So over here we have green and we have red. So we have two colors. And then you have an emblem on each shirt. One is silver, or you could choose gold. So on this, what this means is we have 10 t-shirts that are green with a gold emblem, 8 green t-shirts with silver emblem, and for red we've got 6 that have a gold emblem and 6 that have a silver emblem. Okay, so the question is, what is the probability that the student chooses a red t-shirt? Well, we have to go back to our formula. So that is that you have favorable outcomes, what I want, over possible. Okay, so the favorable would be a red t-shirt. Well, how many red t-shirts do I have? I have 6 plus 6, which is 12. Now I want to know what's possible. Well, how many t-shirts did I make altogether? That's the whole pool of t-shirts. So if I add them all together, 10 plus 8 plus 6 plus 6, I get 30. Okay? So the probability is 12 out of 30. Now, can I reduce that? Yes, I can divide both of them by 6, and it reduces to 2/5. Okay? You can write probability always just as a fraction unless they ask you for a percent. In this case, it would be 2/5 is 40%. Okay? So, is it very likely? The probability is 40%. That is 40%. How likely is that? Well, 40 out of 100, it's less than half. Might be good to know. So actually, less than half of the t-shirts were red. I don't know why they did that, but that's just interesting. Okay, so now I want you to go ahead and do these two OYOs. So go ahead and pause the video and write those down. Let's see what they say. Hello, people are walking in, and the dogs are barking. Okay. What is the probability a student chooses a golden emblem? So we're going back up to number 2. So look at number 2 for that. And then number 2, you toss a coin and a die. What is the probability that you get a tails and a 4? So you have 2 events that are connected. First you flip the coin, then you roll the die. So go ahead and pause the video, and we'll come back in just a few minutes. Okay, let's keep going. So we'll go over this. What is the probability a student chooses a golden emblem? Well, if I go back up here, gold is 10 and 6. So I've got 16 out of the whole thing, which is 30, favorable over possible, and that reduces to 8 out of 15. And if you look at it, it's just more than half. So they made about half. So that's our answer. Okay, you toss a coin and a die. Well, I rewrote all of our possibilities because we had this problem earlier. It was number 1. So I want to recall all of that. So we have tails with every number, and then we have heads with every number. So our possible outcomes, remember, favorable out of possible. Okay, tails and a 4. Well, I only have 1. So what's the likelihood I'm going to get that? 1 out of all my possibilities. That's 12. Okay? So that's that. Okay. Now we're going to go on to something called experimental probability. We looked at theoretical. Now we're going to do experimental. And that is the number of successes over the number of trials. Now this is different words. We're not looking at possible or favorable. We're looking at what actually happened. So this is not hypothetical. It is an experiment that already occurred. Okay, so we have successes we got when we did it out of how many trials we did. Okay, so here's an example. This is number 3. You can go ahead and pause the video and write this down. Each section of the spinner has the same area. So here's our spinner, and there are 4 colors: green, yellow, blue, and red. The spinner was spun 20 times. So there's our experiment that already occurred. For which color is the experimental and theoretical probability the same? So that's why this is important. There's a difference between the likelihood that something will occur and what actually happened. Do you see the difference? So both are probabilities, but one is, but they can be different because what actually happens doesn't always line up with what we think should happen, right? I mean, you make plans, best laid plans. Now, of course, this is something you learn later on, farther along in probability. The more events you have, like the bigger your sample. So let's say you ask 30 people a question versus 500 people a question. The more that you have, the more reliable that it will actually represent a whole huge population. So as we're seeing on TV right now, they're talking about studies. Many studies about the coronavirus and medicine and all different things. And when you have a study that only has 10, 20, 30 people in it, that's much less reliable than a study that has 1,000, 2,000, 3,000. That it actually, the experimental probability is more accurate. Super important to know. Okay, so when you're watching TV with your parents, or they're talking about the coronavirus, or people that you know are doing that, when they talk about a particular study, you can question it more, or you can believe it more, the bigger the sample size. Okay? All right, so now let's see what we have here. So here is the experiment. This is what happened. The experiment happened here. When we spun 20 times, this is what we got. Let's talk about what actually happened, okay? So with red, we had 5 out of 20, so that reduces to 1/4. With green, we have 9 out of 20. That doesn't reduce. And blue and yellow, we both have 20. 3 out of 20, okay? Now, what is the theoretical probability? Well, you can see here that we have a spinner that has 4 equal parts with 4 things in it. So when you spin it, the chance that you will get one color, any one color out of all colors, which is my possible, that's going to be 1 out of 4. So which of our colors actually gave us where the theoretical matched the experimental? That would be red. So the answer is red. Okay? I hope you're seeing the difference between what we think should happen and what actually happens. And as I said, the more trials that you have, more likely that the theoretical and the actual will match up. Okay, we're going to talk about the next idea and the last one, which is called odds. When you're looking at odds, you are looking at not the total of things happening, but of one event against another. All right, so when we have odds in favor of what we want, we have our favorable outcomes over our unfavorable outcomes. What I want versus what I don't want. Okay, so we could word it like that.
Yes.
What I want
No, yes, taxes and, no.
out over what I don't want.
Not taxes. No, they're not escrow for anything. I think taxes.
Okay, I'm going to rewrite what here. Okay, now odds against would be the opposite. So odds against what I want, do you see the difference? They're just flipped. So I have favorable over unfavorable, and here I have unfavorable over favorable. So this is the same as what, hey Chris, can you keep it down please? What I don't want, I guess not, what I don't want over what I do want.
Yeah, now let me see real quick. Let me go real quick.
Just 1 second, go ahead and write that down. Okay, so let's do an example. All right. Go ahead and write this down. Find the odds against stopping on green. Okay, so odds against. My formula is the number of unfavorable over the number of green. Well, unfavorable would be not green, right? And the number of green would be the number of green. So how many do I have here? Well, each color is the same size. So I have 1, if I got it, that would be 1. So I've got 4 possibilities, and 3 of them are not green. So that would be 3, and green is 1. So the odds against stopping on green are 3 to 1. Now, can you see how knowing that would be really important? Because then you go, oh, okay, not very likely I'm going to get green. Okay, or it's very likely that I won't get green. So putting a number on it actually really helps us to understand what the odds are. Okay, so I want you to go ahead and do these odds, or these OYOs. In number 3, which color is the experimental probability of stopping on that color greater than the theoretical? So just to help you remember, number 3 was the one where we did the actual experiment. I rewrote our results here. So which one of these is the color, the actual event happened more often than we thought it would, okay?
So let's talk.
And then number 2,
So let's talk about the definition.
in number 4,
Right.
what are the odds in favor of stopping on blue? So go back up here, and I want you to find odds in favor of stopping on blue. So please go ahead and do those, and we'll come back in just a minute.
Well.
Okay, let's go over these. And let's talk about it. So, in the favor of, which one is it? Okay, well, the theoretical probability, remember, was 1/4 for any color, right? And we've spun the spinner 20 times, so that was 5 out of 20. So which one of these colors is more than 5? Well, obviously, the green. So here, the green would be the actual experimental probability. What happened was greater than what we thought would happen. Okay, number 4. What are the odds in favor of stopping on blue? Well, remember, odds in favor are favorable outcomes over unfavorable, right? So we're looking at, up here, this. I'll redraw it up down here. You probably already did. Okay, so in favor of blue, well, I only have one, so I can only get blue in one way, and what's unfavorable is the other 3. So it's 1/3, 1 to 3. That's the favorable odds of getting a blue. Okay, that's it for today. I hope you enjoy probability, and I will send the homework to you very soon. Have a great Wednesday. Bye now.